So hello everyone, welcome to this another video of Scale Up India. In this video we are going to discuss about streams API in Java. So first of all, let's understand why do we need streams. So here we are going to have a particular case study, and that case study we are going to implement with the help of a code before Java 8, assuming that we don't know anything about lambda expressions or method references. Then we are going to enhance the code with the help of lambda expressions, and then the same code will be enhanced with the help of method references. In case if you are not aware about lambda expressions or method references, then you can watch my video on lambda expressions. The link is there in the I button. And later on, the same code we are going to enhance with the help of streams. So without any wasting time, let's directly move on to our IDE. So now we are in our IDE, and let's get started with demo 0. So this demo has been implemented with the help of Java 17, and here this is our case study. So first of all, we have a particular entity package where we have a class known as employee. Now in this class, we are just having three variables: ID, which is an integer, name, which is a string, and marks, which is again an integer. Then we just have a normal parameterized constructor, some getter methods, and a toString method. Now we have one more class which we call as generator util, and here we have a method as populate employees. So what happens is that whenever we are going to call this method, it is going to return a list of employees. Now since this is a static method, we can directly call this with the help of class name. Now this method will provide us a list of 6 employees here, where you can see a particular employee has been duplicated but with different marks. And besides this, we have something like demo 1. Now in the demo 1, what we are doing is that first of all, we are invoking the method populate employees. Then we are saving the data in this list as employee list. Now if you don't know how do lists work or how do the collections work, then you can watch our video on collections. There is a separate video available for this. And now let's directly move for the next part. So first of all, let's just see what the data do we have in this particular list. So here we have an enhanced for loop, and I'm going to execute the same here. So as you see, this is our input list, and here we are getting printed all the employees because I have overridden the toString method. So all the employees are getting listed in the same order, and by this we will get an idea that what was the input. Now for the output, we have to perform some particular task. So first of all, they say that in this demo, we cannot make usage of anything like lambda or method reference or stream. So hence we are going to assume that we don't know anything about these. Now, the requirement is that we need to filter only those employees whose marks are more than equal to 60. So let's see how we can do this. So for this, we are going to make a for loop, and we can say here employee. So this is my employee, and then this is the employee variable, and I'm going to iterate this over the employee list, something here. Then after this I will say if condition, and in that I will say if employee dot get marks is greater than equals to, let's say, 60. So these are the ones which I need to fetch out. So if it is greater, then I wish to add these employees in some different list. So let me just create a new list for this, an empty one. So I'll say list here for the employee, and let's call it as something like employee list 2, or better we can call it as something like filtered list. So that's a better name here. Now we can make it either like a linked list or an array list. Any of them will be fine here because it's just a small data. So here we will say this, and let's say brackets, and that's it. So we'll say Control Shift O so that it gets imported. Now we are going to add the data to this list. So we will say filtered list dot add, and we can add this employee as it is. So now this filtered list is a list where we have only those employees whose marks is greater than equals to 60. Now the next requirement is that we need to sort these employees on the ascending order of their names. So let's assume that as of now we didn't read this statement and we can directly print the employees. So let's see. So for this one, what I'll do is I'll just copy this particular for loop and I'll paste it out here, and I'm going to iterate this over the filtered list this time instead of the employee list. So let's see what is the output it is going to print for us. So let me just drag this and say execute. So when we execute this, you can see that initially we were having 6 employees and now we are just having 3 employees. But first of all, we are getting John, then we are getting Abhishek, and then Yuvraj. So that means that these employees are not sorted by their names by default. So the requirement is that we need to sort them before printing. Now, in our collections video, you also saw that how we are going to sort a particular list. So for that, we are going to make usage of this collections class. So we'll say collections.sort, and here this is the one. Now to this sort, we are going to have multiple overloaded methods here. So we are going to make usage of this one, where we are going to provide a list as well as a comparator. Now the details are available in the video of collections framework. So let's provide this filtered list here. So this is the one. Now since I have not implemented the comparable interface, hence by default it is not going to sort, and we need to provide a comparator. So I'll just go here. Now if you think how I came to know that I need to implement a comparator, so again I'll just go here and say control space, and you can see this is the one. So I need to make usage of this one now. So we'll say new of comparator, and this is a comparator for the employees. So let's say employee, and now we'll say something like this. But since comparator is an interface, so we cannot directly instantiate here. So we are going to create an anonymous inner class for this, something like this, and there let's implement the unimplemented methods. So we are going to import it from java.util, and let's implement the unimplemented methods. So now here it goes, our compare method, and let's remove all these things also. And here we need to do this on the basis of their names in the ascending order. So what I'll do is I'll say here o1 dot get name, then I'll say compare to, and in this I'll give as o2 dot get name again, and there it is. So this is the one, the comparator with the compare method. If you didn't came to know that how I wrote this, for that obviously you know that you not need to watch the particular video. So let's execute this. So now you can see that the second list is sorted this time. So first we are getting Abhishek, then the name is starting with J, then the name is starting with Y. So now this is a sorted list. So what we did here was, first of all we created a new list, empty one, and then we filtered only those employees whose marks is greater than equals to 60. Then we sorted it with the help of collections sort method on the basis of name, and then we again printed the same. So this is the one, and normally I guess if you will also get any task like this, you will do something like this only. Now let's copy the logic from here and close all these classes. So now let's move on to our demo 2, and here again we need to perform some similar task, but this time the advantage is that we can make usage of the lambda expressions. So let's do the same thing with the help of lambda expression this time. So first of all, what I'll do is, again I will be creating a new list, or what I can do is I can copy the previous logic. So let me just copy paste here, and now they say that we can make usage of lambda. So can we use lambda something here? Currently the answer is no, we can't make usage of lambda. Can we make usage of lambda here? The answer is yes, here we can do. So we know that here we need to implement comparator only, and in the comparator we have this compare only, there is no other method. Or also if you wish, we know that lambda can be written only for the functional interface. So let's see whether comparator is a functional interface or not. So we'll see that yes, it's a functional interface and it has only one abstract method as compare. So what we will do is we will remove all these extra things, the unnecessary ones, and from the body also we will remove all these extra things again. And let me just take this one also out. So it's here, and between the arguments and the body, let's keep an arrow here. So let's make it like this one. So now you can see I have written the lambda expression here, and we can even make it more shorter, that I can remove this thing, because we know obviously employees are only going to come here. Anything else is not going to be appeared. So now if I save and execute something like this, so this is going to work fine. Abhishek, John, Yuvraj, everything is there. Can we make it even more shorter? Let's see. So here we are using the enhanced for loop for iterating over the list. Now what we can do is, since Java 8 onwards, we get some more methods, and the method is, so first of all we will say filtered list here, and one of the method is this one, for each. So we'll select this. So let's hover over to this for each method, and if I open the declaration, so you will see that here we have this particular for each method where the enhanced for loop is already available. So what we can do is we can utilize this, and as you see, it can take a particular consumer. So let's provide a consumer here. Now consumer, as you know, it always accepts the data. So it is going to accept an employee because it's a list of employee only. And then what we wish is that we want to print the data. So we'll just say sysout, something like this, and there we will say employee. So this way we can do, and we don't need this semicolon here. And now we even don't need this particular statement. So this is the stuff here. And if I execute it again, then again you can see it is going to work fine. So this is interesting. Now onwards, you don't need anything explicitly like an enhanced for loop or a simple for loop. You can directly make usage of for each. The only thing you need to remember is that from for each, you can never return the things because it's a consumer type. Now, can we convert this also to for each? So let's see. So here we have a list of employee. So we will say employee list dot for each, and here also let's just copy paste this only because the content is same. So this one also we have replaced like this, and we don't need this one also. So this also now looks good. Now can we change this part also? Let's see. First of all, we need to understand, are we returning anything here? The answer is no, we are not returning. We are just iterating upon the employee list, and then we are filtering, we are checking if the marks is greater than equals to 60, and if yes, then we are adding the data to a different list. So yes, that means we can make usage of this for each method. So what we will do is we will copy this, we'll paste it out here, and then we will say it is going to take an employee, something this, and then here we have multiple lines. So what we will do is we will make usage of these braces since we have multiple lines this time, and inside this we will copy this logic, the if condition, and we'll just paste it out here. And now we don't need something like this, so we can make it this one, and we can say, let me just select this part only and say Ctrl Shift F. So here it is, this is the way it is looking. So we are making usage of for each. There it is a list of employees, so we are getting. Then we are saying if marks is greater than equals to 60, add the data to another list. So this one is also looking good, and we can say Ctrl Shift O to remove the unnecessary imports now. And if I execute, so again this looks good. So you see how Lambda has made our job simple this time. Now we don't need to write too many lines. So earlier, if you compare, earlier we were writing almost like 44 lines of code in total, including these comments and everything. Now comments and everything is same, but the number of lines are 34 only. Now again let's copy this logic and move on to the next demo 3. Now this time they say that you can make usage of lambda and method reference, and here they have already made usage of lambda. So let's paste it out here and see that how we can make usage of method reference. So you know that method reference can be used when we know that whatever is the input we are going to use as it is in our methods. So here you see that this employee we are printing as it is. So what we can do is we can remove it from here, and we can remove this particular part also, and here we can say double column. If you don't know how this worked or what are the complete details of it, then you need to watch the video on lambdas. Same we can do out here also. Let's remove this particular thing, and let's remove the things from here also, and let's say here colon. So this is how it is going to become short and simple. So there is no change in the number of lines. They are still 34, but your code is now looking even more smaller. Can we make usage of the method reference here? Currently the answer is no, because here we are doing too many things. Can we make usage of the method references here? Again the answer is no, because input is an employee object and we are making usage of get name. So it is going to become little difficult, and hence it's not possible here. But what we saw is that if we make usage of lambda and method reference only, then also our code is becoming shorter. So what is going to happen when we are going to make usage of streams in future? Now before we can make usage of streams, we need to understand what are streams. So for that we need to move on to our PPT. So now let's discuss what are streams. So this is the streams. So this is the general thing. As you see, what is a stream basically? Stream is something like a flowing thing only. It is not going to store anything in itself. But the point is, this is the stream which nature is going to provide us. This is not a Java stream here. And we are going to discuss about the Java streams. So let's move on here. So streams in Java are a powerful abstraction for processing collections or sequence of data in functional and declarative manner. So here you say they are going to work upon your collections or any sequence of data. And how? With the help of functional and declarative method, which means they are going to make usage of the lambda expressions and the method references. They allow you to perform various operations like filtering, mapping, sorting without explicitly writing loops. So this time we don't need to write any loop at all. We don't need to iterate over the data at all, and directly they can help us out. Now they became the part of Java since Java 8 only. Before this, streams were not available, and hence many of you may not know what streams are. Another best part of streams is that streams are lazy in nature. So sometimes you see in the real world that we should not be lazy. But here the best part of streams is that they are lazy in nature. So as of now, just remember that it is also a feature, and by the end of this video, you will get to know that why we are calling them as lazy and why is it a useful feature. But as of now, assume that we have just explained it theoretically that yes, they are lazy. Now let's discuss what is the difference between streams versus collections. So many times people get confused that if collections is there, then why do we need streams? Or if streams is there, then what is the purpose of collections now? So let's see. So collections are the data structures which is going to store or organize a group of objects, which means they are basically going to store the data either in the format of a list or set or queue or maps. While on the other hand, streams are never going to store the data. They are just going to process the data which was stored in the collections. So this is the same difference between a particular glacier and a natural river. So you know that in the glacier, at those places we have a lot of water stored by default, and when the temperature rises, the same water is going to come in the format of rivers to us. So rivers never store the data in themselves. The water just keeps on flowing. Same way, data will never get stored in the streams. It will just keep on flowing. And in order to store the data, we still need to make usage of collections. Now let's see the same thing with the help of some examples here. So whenever we are going to work with the streams, we need to have basically three things. First of all, we need a source. So here you can see these 9 numbers are a source. So you can assume that either these are just numbers, just a sequence of data, or you can assume that it is a kind of a collection. It can be a list, it can be a set. Then we need to have a particular pipeline for our stream. Now how to convert this data to stream? So with the help of this particular pipeline. So this is going to convert it to a stream. And then after this, let's say we want to filter out. So again, we will put one more pipeline in the process. So what it will do is it will just identify that what are the even numbers, and only the even numbers will be allowed to move after this particular thing. And then at the end, we are going to have a particular sink. So the another example for this can be that water is stored somewhere. Then how does it comes to our house? With the help of the pipelines. So these are those pipelines. Now in these pipelines, you can perform any kind of operation, and at the end it is going to be synced, where it will come with the help of tap in our houses. But as of now, this is not going to work directly. The reason is that this filter is an intermediate operation. In order to get this work, or in order to get some kind of output from this to the sink, we need a particular terminal operation. So filter is just an intermediate operation. So let's see that how the terminal operation is going to look like and what kind of data can we get from this kind of stream. So this is the one. So again, everything is same, source is same, filter is same, and there is our sink. So the first option is we can sync the data as it is after it gets filtered. So let's say we just want to print out the data on our console, or we just want to display it to the user. So now since print is a particular terminal operation, our stream is going to start this time whenever the print will get called. So it is going to work like this. So now you see the data is just coming. Since 1 was an odd number, so it got filtered out. 3 is an odd number, it got filtered out. 4 was able to pass. 5 again got filtered out. 6 is able to pass. 7 got filtered out here, but 8 was able to pass on here, and 9 again got filtered out. So in the sink, we got again some kind of data directly. Now this is not a list, we just printed the data as it is with the help of a terminal operation, but it came out after getting filtered. So this is one way of sink. Another thing which you can do with the sink is that you can get a single value also. So let's say that you want to get the sum of all those even numbers. Again, sum is a terminal operation for us. So this time, this is going to be the behavior. 1 will come, it will get filtered out. 2 will come, and it will come till this point. Then 3 will filter out, and 4 will pass the filter. 5 will filter out, and then 6 is again going to pass the filter. 7 will get filtered out, and this number 8 is going to pass the 1. Once the 9 will also get filtered out, we are going to get a sum out of this. So this time in the sink, we are not getting the data as it is. Instead, we are getting the sum out of it. So streams can help you with this part also, that it can provide you a single particular sum, or it can be, if let's say there are strings, it can give you some kind of concatenation. Then let's see the third kind of operation. So assume that at the end we just want a new list again. So again, this list also can be a terminal operation. Now this list is not the actual word as it is, which we are going to use in our coding. This is just for depicting the things so that you can get an idea how the things are going to work. So this time 2 will go till list, 3 will get filtered out, 4 will be able to pass the filter, 5 will get filtered out, and 6 will be able to pass on the filter. Then we can see 7 will get filtered out, and 8 will be able to pass the filter, and again 9 will get filtered out. Once it is done, we will get a list out of this particular stream. That is a list of even numbers only. So from the streams, we can get either a collection, we can get a single particular number, a single data, or we can get a data as it is. But we need to ensure that for this, we should have a particular terminal operation. In between, we can have any number of intermediate operations, and that we call as a pipeline. And in the starting, we should have a particular source. Now let's see that how we can code the previous example with the help of streams directly and efficient. So here we are. Let's directly move on to our demo 4. And this time I am not going to copy paste because maybe you have forgotten what we did last time. So let's directly do here. So this time they say that you can make usage of lambda, method reference or stream. So that's an advantage to us. Now first they say is that first of all we need to create a stream. So if you remember from the PPT, first of all we made stream out of a collection. So let's see how that can be done. So here we will say employee list, this is the one, and then we will say something like, we will just start with an S and then we'll say control space. So with this control space we will get all these operations. So let's see if we have anything like stream. So this stream method is available here, and what it will do is it will return you a stream of employee. So let's double click on it and get a stream of employee out of this. So again we can save it here. So let's say stream, then we will say employee something this, and let's call it a employee stream. That's a better term here. So here it's an employee with E small, employee, and then this is a stream, and let's say equal to symbol, and this we need to import. So we'll say control shift O here, and it is again going to come from java.util, and then again we have a sub package there, that is stream. So java.util is a basic utility package from where we generally get the collections, and then we have a sub package there from where we can get our stream here. Now so we got something like this. Now can we directly print, or let's say before printing, the requirement is that we want to filter those employees whose marks are more than equals to 60. So let's see. So let me just copy this one here, and now I want to perform some filtering here. So I'll just say dot, and let's see. So again these streams itself are going to provide us so many methods like your collections provide, and out of these methods it is not again possible to remember all of them. So we just want to see what we want to use. So we want to filter out. Let's start with writing as F here and see if we can get something. So yeah, filter is there, and what it is going to accept, it is going to accept a predicate, and what it says is it returns a stream again consisting of elements of the stream that match the given predicate. Now if you don't remember what is predicate, then you need to watch the video. If you remember, then it's good. So here we need to have a predicate. So you know that predicate always takes a particular input, and the output is always true or false. So this is our input, and in the output we will say we only want those employees whose marks is greater than equals to 60. So something like this we are going to write it out here. So let's say equals to, and let's say 60. So this we have mentioned here, and what's the output? It is again a stream. So from filter also you will again get a stream. So let me just copy this and give it a new name. So I wish to give a new name here, and let's call this one as our filtered stream. So this is the one. Now the next goal is that we need to sort these employees in the ascending order. Now you remember that when we were working with the help of list, there we were able to sort it with the help of collections. So here how can we sort? Let's see, with the help of this filtered stream this time. So again we will say filtered stream here, and let's say that if we have anything like sort. So here we have two methods. The first one is sorted, but this method, let's see, will this method works? So yeah, it is giving some kind of output, but will it be able to sort it by the names? So the answer is no. It will not sort them by name, because it will only work when you have implemented the comparable interface. Currently we haven't, hence this one is not going to work for us. So we need to go by the another option where we need to make usage of comparator. So let's see, and for the comparator what I'll do is, or let me just write a comparator again here. So we'll say this new of comparator, this one, and this is on the employee here, and this is going to have a particular body also this time. So this is the one, and let's say Control Shift O so that it gets imported and implement the methods. Now here is the logic, and let's remove this commented line too. So we want to sort them by name, so let's say o1 dot get name this time again, and say compare to, and then let's say o2 dot get name again. So this is the one. But yeah, as you know, we can make it even more shorter, and we are allowed to make usage of lambda. So we don't need anything like this because we know only comparator can be written here. So no need of this, and also we don't need anything like this here. So let's remove all these things, and from here let's remove this return keyword and braces and just put an arrow symbol here. Here also we don't need this employee because we know only employees are going to come, anything else is not going to come here. So this is how it is going to look like, and what it is going to return. This is again going to return a stream. So let's copy this, and this time we are going to, let's say, call it a sorted stream. So let's say sorted stream. So this is the one we have got now. So first of all we got a normal stream, then we filtered it out, then we sorted this, and now the next goal is to print them. Now for printing, just now we learnt that we can make usage of for each directly over the list, and in the for each, if we just want to print as it is, we can make usage of method reference. So let's see with this also, do we get anything shortcut like this, or we need to have a complete for loop, or how it is going to work. So here if we say, we will get again a for each, and this for each is same, it is going to take a consumer. So instead of writing again, let me copy and just paste it out here. So in just 4 simple lines, we were able to convert it to stream, then a filter, then sorting, and then we have printed this out. And for this you don't need to remember the method as it is. The only thing which you need to do is, first of all, just convert it to stream. Then you think what you wish to do. Just say control space and then identify, do we have that particular method or not. Obviously for this you need to understand what all these particular default interfaces are. So you should have a very basic idea for all those 4 basic default functional interfaces. Let's say Control Shift O and remove that unwanted import. Now if I execute, so this is going to work fine for me. So after for each, again this is working in the same manner, and this time not even 34 lines. So last time it was 34, but this time it is only 30 lines. So even 4 more lines got decreased here. Now this is good. Yeah. Now let's say that we want to print it 2 times. So what we will do, we will just copy this and let's paste it out here because we want to print it twice. Now if you will ask me why do you want it to print twice, just to show you something. Yeah. So let me just save it and re-execute this one. So this time we are expecting that the same filtered employees, same sorted employees will be printed twice. Let's see. So okay, there is some kind of an issue. So we got the filtered and sorted employees once, but when the second time we tried, it says that stream has already been operated or closed. So what does it mean? This means that this stream, the sorted one, has been already imported. So if you remember, I gave you the example of river that never store the water. Similarly, streams never store the data. Now since they are not going to store the data, which means that you can have a particular operation only once. You can only get the data out of it only once, not again and again. Hence you cannot make something like this. If you want to get, then again you need to start from the base. You need to convert the list to a stream, then filter, then sorting, and then again you can print this. So that is the case here. So let's just keep it till this point. And what we will do is, we'll just do something more interesting. Let me copy this demo 4 and create a demo 5 here. Now in this demo 5, again we have a same code we have just copied. Now the point is that since I cannot reuse this sorted stream, then should I save it here? I mean, generally in Java, why do we save our data in a particular variable? Because we want to reuse it, right? Otherwise, what is the fun of just saving it if you don't want to reuse? But the problem here is that we cannot reuse the data. So if we are not able to reuse the data, then why to save a filtered stream in this one? Instead of it, we'll copy this particular thing, or let's directly cut this particular thing and put it here. Simple. And now we don't need something like this, a sorted stream. So directly upon the filtered stream, we can say sorted, and after sorted, we will say for each. So now it is a pipe. So this is the one. Now again, can we reuse this particular filtered stream? Answer is no, we can't. So again, let's cut this particular part and let's keep it out here. And let's remove this particular line. So again, this is done. So it's an employee stream. We are filtering this, then we are sorting this, and if I scroll, then we are printing also. Then again, can we reuse this? Answer is no. So if we can't reuse, so let's cut this out and print it here, and let's again check how it looks. So this is how this is going to look like, just in 27 lines of code, and I can say Ctrl+Shift+O. So it is now 26 lines of code after removing the unwanted imports. And the best part is, whatever you were doing, basically, like if I open the demo one again, so whatever you were doing in almost these many lines, these are around like 10 or 12 lines. Now you can do the same thing in one single line. Obviously, if you say that now it is little less readable because we need to scroll and do all these, so the shortcut which you can do is, before every dot symbol, you can say enter. And before this sorted also you can say entered, and before this filter also you can say enter, and then it is going to look something like this. So here, let's see. So now you can see, first of all, we got a list, we converted it to a stream, then we filtered this out. Filter is an intermediate operation. Then we sorted this, again we got a stream. So this is an intermediate operation. And then we went for the for each. Now for each is a terminal operation. It will never return you anything. The output is a void. So after for each you can't write anything. So this is the way your streams are going to work. And the benefit it is going to provide is, it is going to make your code even more shorter. And this is how we are going to achieve the functional programming in Java itself directly. Now you don't need to say it how to do. You just need to tell it what to do. So you are saying that filter those employees whose marks is greater than 60. It did. You then said that sort the employees by name. It did. And then you are asking it to print. So that also it did. So it is just a simple code. And again, you should not say these are now 4 lines. It's a single line. You are using this semicolon only once, not again and again. We have done this just for our readability. So this is the benefit of making usage of the streams. So I hope now you are convinced and now you are ready to make usage of the streams API for your code. But we are not going to stop here. We are going to understand many other methods and many other things step by step, that from how we can get the streams, what are the different kinds of methods we can do, how we can show the output. So all those things we are going to see in our upcoming demos. This was just a trailer. So, and I hope you like this particular trailer. So let's close this thing and move on to our PPT. So now let's see that how we can generate streams from different kinds of inputs. So for this, let's go to our IDE. So here we are, and let's open our demo 1. So this is my demo 1 here, and here let's see what the problem statement we have. So here for the first one, they say that you need to create a stream from a given list. So we have just now done the same, and this time it is even more simpler. It is a list of integers, so data is already there. We just need to create a stream and we need to print the elements. Let's see how we can do this. So we can say list dot stream, and this is how we got the stream directly. And then directly upon this also we can say dot, and then what we can say for each, and inside the for each we just need to print the element. So if you are not comfortable with the method references, then you can say data, and then you can say arrow, and then you can say here sysout, and then again you can say data here, and this semicolon we can remove from this. But since whatever we are getting we are just printing as it is, so let's make usage of the method references. Let's remove this, and let's remove this also out, and here let's say double colon, so that it looks even more crisp. And this is how it is going to look like. We have converted it to stream, and then we are saying for each. If you wish, and if you don't feel comfortable directly writing here, then first you can save the data to a stream, and then upon that you can say for each. But here, since just now we saw that there is no benefit of saving the data first, so directly we are going to print the contents. And let's execute this one. So if I execute this with the help of a Java application, so this is the output: 20, 30 and 10. For others we didn't got the data because we are not printing the same. Now for the second one, they say that this time you need to create a stream from the set. So a collection can be a set also. So let's see how we can do that. So again we'll just say a dot, and let's see if we can directly convert it to a stream first. So we'll say, yeah, stream is again there. So we'll say stream, and let me just copy this. I mean, you can try to become as lazy as possible. I mean, even streams are lazy. So while learning streams, why we can't be lazy? So again, this is the output here, and we will see the output, but let's first of all see the map also. So for the map also, they are asking us to convert it to a stream and print. So let's say map dot stream if possible. So on the map, you see that we are not getting this stream, which means that you cannot convert a map to a stream as it is. That is not possible, because directly upon a map you can't even iterate. So you need to look for some other options. So let's see what other option can we have here. So if you remember, in the video of collections, we learned about something like entry set. So can we get an entry set here? So this is the one, an entry set. So this is going to return you a set of entries here. And what is an entry? Entry is a combination of your key and value pair. So you can see the output is going to be a set, which is an entry. An entry is what? Integer is your key, string is your value. So this, now since this is a set, upon set you can just again write something like this. So we will just copy this same thing, here it is, because now we are creating a stream from a set, but this set we created from a map, and this is a entry set. So it is going to have the key value pair by default. This entry set again we have explained without streams in more detail in our collections video. So let's execute this and see how the output is going to look like for all of them. So for list, you see all the numbers are getting printed. For the set, again you see everything is getting printed out here. And for the last one, since it's an entry set, so what is an entry? Entry is a combination of key and value, and this equal to symbol is there by default. So we are getting this, something like this one. Now if you say, what if we don't want to print the map value something like this? I mean, we don't want this equal to symbol here. We want to print it in some different way. Then again there is a shortcut here, and that shortcut is, we will say map dot, let's say again entry set, then let's say stream, and then we will say this for each here, and this time let's say we will say entry is the input. Now from this entry we wish to print entry dot get key here first of all. Then we will, let's say we wish to have some space, and then we wish to have some this colon symbol, and then let's say we wish to say entry dot get value. So this is the one. So this way also we can try this out. But okay, here we have made a mistake. We are not writing the sys out here, so we need to tell that too. So let's say this one sysout, and this is the one, and we need to write all these things in our sysout here. So now this is going to look fine. So as you can see, and now if I execute the same code, so we can see it will appear like this. This is for the first output and this is for the direct second output. In this video, as of now, we are just going to make usage of our direct second output, but now I have shown you how to manipulate the key or the value in the way what you want. So now this is also done, and now we know that how we can convert it from a list or a set or directly from a map to. Now let's see what do we have in our demo 2 here. So this time they say that input is an array. So this is not a collection, but we know streams can work on the collection also or any kind of sequence of data. So now when we wish to convert, now here let's see if we can say array dot, okay, here we are not getting anything like array dot to stream or something like this. So that means there is going to be a different way. So this time we will say stream, then we'll say dot, and we will say off. So this is the way. So we will say stream dot off, and then we are going to pick the first one, and here we are going to provide our array. So whatever is the array, you can provide here as it is. And now we have converted it to a stream, and then we can print it as it is. So let's see how we can print this one. So on executing, you can see that I'm getting this kind of output. Stream from array is 20, 30 and 10. Don't worry about this null pointer exception, because for all others as of now we have made it null, and on null if we will do something like this, it will give us null pointer exception. So these are also we are going to study after this. But now we know how we can convert it from a stream, or sorry, how we can convert a stream from an array. So that is done. Now the second one is that this time we don't even have a array. They are asking us to directly convert the data to a particular stream. So let's see. So we will again say stream, we'll say off, and then you see here we have something like this. So this is a particular vararg. So we have a particular short also on this particular vararg. They are not much views, so if you wish you can provide some views to that particular short also. It doesn't need a full video. So if this is the one, and here let's say we wish to have this particular same data only, so let me copy and paste here by comma separated. So this is how it is going to look like. So you can create a stream directly out of a data. Now I will print it together only. Now the next one is that this time that you need to create a stream but from random generated data. So you can't say dot off and then you can directly put some data. They are asking that you just want to print some random data. Let's see how we can do this one. So we will say stream, and this time we need to say generate. So here let's see if we have any generate method. Yes, it's there, and it is going to have a supplier kind of argument. Now what is a supplier? Supplier, if you remember, it never accepts something, it always return the things. And what do we want to return? We want to return a random generated data. So we'll go for this generate, and here we are not going to accept anything from the user, and in the body we are just going to generate the random data. Now in Java that can be done with the help of a random class. So we will say new of random here, and then we will say next int. So from this random we will just keep on taking some integers, and so this is going to be our stream, and let's see how this is going to work. And for this I need to import. So yeah, that is done. So this is my second one, that this time I'm going to generate a random data. So let me just execute it and see. So you see the code is not getting stopped. The question is why it is not getting stopped? Because the problem is that this is an infinite stream now. By mistake, we have created an infinite stream because we are saying that to generate data, but how much data should it be generated? By default, it can generate any amount of data. So for this, in order to make it a finite stream, we need to say that it should be generating only 5 or 10 or something, these many elements. And that we can do with the help of one more stream method, that is dot limit. So we are going to discuss about this afterwards in more detail, but as of now let's use it directly. So we'll say limit, and there we will say that we just want to generate 3 numbers like this. So this is going to generate you 3 numbers, and if I execute, so yeah, these are the 3 numbers, and it can be any number because we just asked it. So it can be a positive, it can be negative, it can be any. So yeah, this is done. Now for the next one, they say that create a stream, but not for random. It should be starting with 1 and then print the elements. Okay, so let's see. So we'll say stream and then we'll say dot. Now this time they say the word iterate. So yeah, here I can see there is a word iterate. So let's use this, and what it takes is, first of all, it takes a seed. So the seed is nothing but the very first number from where what is going to be your starting point, from where you wish to start. And then it takes a unary operator. So what is this unary operator? Unary operator is nothing but you can say it is a kind of function only. The only difference between a function and unary operator is that in function you are allowed to take any kind of input and return any kind of output. But in unary operator, whatever is the data type of input, same is the data type of output also. So we'll say the seed is 1, that is a starting point, and then we are going to get, or we are going to start with an integer. So let's denote it by I, and then let's say that we just want to increment and return the particular value, something like this, I plus 1. And here it is the way to write the same. Now if you wish to see more details about unary operator, then I won't say that you watch that particular video, but you can just identify or try it out on your own, because I have already shown you how you can see the complete documentation of any of these classes directly. You just need to say here new of unary operator and then just hover over to this and open the declaration of that particular class. And let's print this thing now. So now this is the output, guys. Okay, again this is too much output, and the reason I hope you is clear, because we have told what is the starting point, we have told how to increment, but how to limit. So for this, one option is we can make usage of this limit. Let's see, do we have any other operation also? Okay, there is something like has next. So there is a predicate also. So this is the one which we can make usage of. So one option is you just give a starting point and the condition to increment or decrement. Another operation is like a for loop. You give a starting point, then you give some condition. If that condition meets, then it will keep on iterating. If it doesn't, then it is going to stop. Yeah, but as of now we are not going to use this predicate, and let's, or if you wish we can make usage of that too. Let's directly see that. So in predicate, what we will do is we'll put a comma here, and let's say like this. So we are going to start with I, but we wish that this I should be less than equals to, let's say, 3. So this is my condition. So is this going to work here? So here it says that I cannot be resolved because we directly gave a condition. Is this a predicate? Answer is no. We need to look it like a predicate. So let's say I, that is the input of predicate, and then this is the body of predicate. So this is just your seed, this is your predicate, where this is the input, this is the body. Then this is unary operator, where this I is the input and this I is the body. And now if I execute, let's hope it prints us 1, 2, 3. So yeah, it is printing me 1, 2 and 3. So this way also you can do, or if you wish you can make usage of limit also explicitly. Both of them are fine. And last but not the least is they want us to have an empty string. Now there is no usage of empty string, but just in order to show you the method, I have created this. So here I will say stream dot, and there is something like empty. So now since this is an empty stream only, that means it is not going to give you any kind of output. So we should not expect anything out of this. So if I execute, this is how it is going to look like, empty string. So we have converted our data from an array. directly from the raw data with the help of random, with the help of iteration, and the last but not the least, empty stream. And if you wish, instead of first storing it somewhere and then using the for each, we can make it directly also. But as of now, I'm going to upload this code as it is on the GitHub, and then you can just manipulate it, modify it as per your wish, and then you can see how the things are going to work. So now when we are clear with how to generate streams, let's see some more examples where we are going to discuss that how we can operate on these streams after generating the data. I mean, just generating the data cannot be our final goal. After that also we should be doing something. So let's see what are the different kind of operations we can perform on them. Already you know some of them. So here we are with our demo 2, and let's see. So again we have this particular entity with us, the employee class, a very basic one. Then again we have this utility. Again this time I have two methods, a populate list and a populate employees, sorry, and a populate employees two methods. So these are the two methods we are having here. As and when required, we are going to use them. And here we have some demos. So let's see all of them one by one. And before that, let me close these two. So for the first one, the requirement is very simple. They say that there is a particular list, employee list. You need to convert a stream out of this, which we have already created, because we know for list we just need to say stream and we will get. And then they say just print the employees. So let's see how we can do so. So we will say stream, and you remember we made usage of for each. So this is not going to be difficult for us. We can say for each, and there, since we just want to print, so let's make usage of method reference as it is, and we'll say system.out double colon, and let's say print ln. So this is how it is going to work for us, and that was pretty much simple. So if you see, this is your output. As it is, we are just printing. But I will say that if your goal is just to print the data as it is without doing any operation, then we should never create a stream out of it, because you can make usage of the for each method directly upon your list. So why to take a headache of converting it to stream first? Yeah, but this is only for the showing purpose. Now in all these demos, sometimes I'll show them separately like this, sometimes I'll just combine all of them in order to make the code short, and accordingly you know that you can modify the stuff. But we don't need to save the data at any point of time. We can directly use the things here. So let's clear the console and move on to our demo 2. So with the demo 2, they say that create a stream from the given list. Okay, that is already done for us because we know. Then at the end they say print the employees. That is already done. But in between they say filter the employees. So yeah, we have done this earlier also, and it should be easy for us. So we'll just say stream, and we'll just say dot, and we know there was a method like filter, and this filter method was taking a predicate. Now what's a predicate? Predicate is something which will take a data, let's say employee, and it will give you the answer in the boolean format, true or false. And we want the employees with marks more than equal to 60. So here we will say employee dot get marks here, and then we will say greater than equals to 60. So this is how it is going to look like. And instead of saving it somewhere and then printing, let's make it short like this, so we can directly get the output from this one. If you wish, there is no need of this part also. Directly you can say stream and this and that. So that also is going to become fruitful. Or let's do something like this. Let's remove that particular part. So first, let's from the previous one also let's remove, and let's try to make it as short as possible so that you also feel comfortable while using this particular thing. And here also let's remove this from here, and let's not use this stream and directly say filter. So Control Shift O, and this is the way it is going to look like. If you feel it is too long, so you can make it like this, filter and this one. So now it looks shorter also. So first we convert it to stream, filter, and then printing. Now let's go for the next. So we'll increase our speed step by step. So this time they say filter distinct employees. So before doing that, let's see that currently what is the kind of output we are getting from this and why it says distinct. So currently if we print this, you see that this employee is getting printed twice. ID is 101, name is Abhishek. Here also ID is 101, name is Abhishek. So we don't want two employees like this. We want that if two employees have the same ID, then they should be considered a single employee. And hence we can perform a distinct operation on this. So here we will just say something like this, stream dot distinct. Yeah, that option is there. So we'll just say distinct here and this one semicolon. Yeah, so this is done. And after this, without saving, let's convert it to this for each. And here we don't even need something like this, and directly let's say distinct. So this is how it is going to look like to us. So we have stream, we are using distinct, direct method here, and then for each, no condition, nothing else. Let's execute the same and see the output. Okay, we have executed, but it is not showing any kind of difference. Still we are getting Abhishek twice, because the problem is that you have thought that if two IDs are same, then it should show the same output. But we need to tell this also, that if two people are same, then on what basis we are going to compare them. So for this, let's say how this is going to compare. So it is going to make usage of the equals method in order to compare two objects. But currently the equals method, you know that when we are not going to override it, it is going to check them with the help of addresses. Since their addresses are different, they are considered as two different employees. Now for this, what we will do is we'll go to the employee entity class, and here let's override the equals method. So here we will make usage of Eclipse shortcut. So we'll just say right click, and here we'll say source. Here we will go to this hash code and equals method, and we will say if two IDs are same, then two employees are same. We won't consider their name or marks, only ID is sufficient. So we'll just say generate and Control Shift O, Control Shift F, so that it looks nice. So we got the equals method and it is comparing them by IDs, and the hash code is also there. Now let's see, will this work or not? So here we go and let's execute. So this time you see we are getting Abhishek only once. Now which one will come, first one or second one? So you see that here in our list we were having first one with marks 10, second one with marks 60. So how this works is that first it picks this data, it sees if it was already there or not. Since it is not there, it will be kept. Now when this comes second time, this one with the marks as 60, it will say that this ID is already there and hence this ID is ignored. It is not going to replace, it will just ignore the second one. So this is how it works, and we don't have any issue. We just wanted distinct employees. There was no condition for marks as such. So that is fine for us. And we saw the distinct also. Let's move on for the next one. So okay, here we have two questions. So the first task is that we need to skip first two employees. Okay, let's see how we can do that. So upon this only I'll try to make, so I'll just say dot, and let's see do we have anything like skipping here. So I'll say ski. Okay, there is something like this skip, and what it says is returns a stream consisting of remaining elements of the stream after discarding the first n elements. So whatever the number you are going to pass, those many number of initial elements will be discarded and rest of the elements are going to be returned. So we'll just say skip, output is a stream, and here we will say we want to discard first two elements as per the requirement, and here let's convert it to a single stream like this, and we don't need to save it out anywhere. So this is the output. So let's see will it work or not. So if I execute, for the first one you see we are getting only 4 employees and the first two are skipped. How we can say? Because in the second one as of now we didn't made anything. So first two are Abhishek and Sneh, and they got skipped here, the first two. If you say first 3 will get skipped. Now what will happen, because we have only 6 elements, So what happens if I say 6 itself? Let's have a look. So it is not going to print anything because all the first 6 it skipped. After that there was nothing, so it's an empty. Now what if I say 7 here? How will it skip the 7th element? Will it throw some error, or will it just show this void as the output or nothing as the output? Let's check out. So this time also it's not an issue, which means it can be any bigger number. There is no issue. You don't need to worry. Will it take a negative number? Let's check that too, because sometimes we wish to do something this also. So the answer is it will never take a negative number. The number should be 0 or more than 0, which means number should be a positive but not a negative one. Otherwise it will give you error. So we are ready with skip 2 only as of now. We don't want to test any more things here. The next requirement is that now we just want first 2 elements. So after that we don't want. So this is the reverse of the first one. So for this what we can do? So we will say dot limit here. So this is limit, and what it does, it returns a stream consisting of elements of the stream truncated to no longer than the max size. So at max you can get these many number of elements which you will see. If the list is empty, then obviously you won't get anything. So let's remove all these extra things from here, and this is how it looks like, limit. And if I execute this, let me just remove the unwanted imports. If I execute this one, then you can see that here for the first one it skipped the first 2 elements and printed rest of the 4. For the second one it is just showing first 2 and then limited the output. So we won't use the word skip, but we will say it has limited the output here. And I hope you remember that we used the same limit method earlier also when we were generating the random numbers or iterating over the list. So it is the same limit method. Now the next one. So in the next, our requirement is that we want to sort the elements. So let's see. So they say create a stream from the given list. Okay, that is done for us. This is sort the employees in the natural order. So let's see how we can do that. So on this, we'll directly try to write it here. So we'll say sort, and we will make usage of this sorted this time, because they are saying sort on the natural order. So this is the one, and let's remove this too, and let's remove the things from here also, and let's execute this one. So all others we are not going to check out, or in order to remove the confusion, let me comment the others so that you don't get confused. So for this demo 5, if I execute this demo 5, okay, so let's see what it shows. It says there is some class cast exception because the class employee with the package name cannot be casted to the comparable. So the point is that when you wish to make usage of this sort method directly here, then you need to implement the comparable. Otherwise, how it will come to know what is the natural order? So for this, we'll go to our employee, and here we will say implements. So this is implements, and we will say comparable here, and that is on my employee like this. So this is the comparable, Control Shift O, and then it says override the unimplemented methods. So let's just click on this one. So it says the method is compare to. Again, we have studied about this method in our video in collections framework. So we'll go here and we will say that on what basis we should compare. So what should we keep as a natural ordering? So let's say that IDs are the natural ordering. So we will say o.getID minus, okay, so this will just take one argument. So one will be the current ID, and the other one will be o.getID. So let's see what it does this time. So now if I execute the demo 5 again, it shows me some output, and you see all these IDs are sorted by ID 101, 101 again. This order can be anything because it is completely random, okay, or whatever was there in the input. then 102, 129, 153, 177. If you wish, we can reverse this also. How? By saying O in the starting, and here we can make usage of this, like this again. And now if I execute, the list will be sorted in the natural order again, but the reverse order of the IDs, that is the descending order. So let's convert it back to the same scenario, that is in the ascending order. So this is again a change we did. If you wish, you can keep a natural ordered basis on the marks also or on the name also. That is your choice. But we kept it like this. Now let's go for the second task here. The second task is that now sort employees by marks in the ascending order. So one option is you can go back there and you can sort and then again make usage of this sorted. But like this, the requirements will keep on coming at the runtime. Now they may be asked for marks, later on they may ask us for something like something different, maybe the name or some other things. So again and again we should not change it, and now we should make usage of the other sorted method, that is comparator, the one which we used in our demo 0 also. And this will take a comparator. So let's try to do that directly, or if you wish we can again do step by step so that you can get a idea also that how this needs to be done. And here we will say it is going to be an employee, something like this. We will say Control Shift O, and here what it says, okay, here let me say like this semicolon, and here it says add unimplemented methods. So we got this here, and this time we need to do it on the basis of marks. So we will say o1 dot get marks dot compare to, or not compare to because these are marks, so we will just say minus, and we will say o2 dot get marks here, something like this. And we know that we can remove all these extra things, we can make it cut short. This will be replaced by your arrow. This return keyword is also not needed, and these braces are also not required here, and these also we don't need, so we can even make it more shorter here. And here what is the extra? So okay, this one bracket I guess we missed here, so now it looks fine, and this thing we can again keep somewhere here. And after this, let's print also the same thing, and for this obviously I need to scroll a bit, and I'll say this for each here, and this output also I don't want to store. Okay, that was a big task, but now it looks fine for us. So we have converted to a stream, then we are sorting it, and then we are printing the same thing here. And if I execute, so you see that for the first one they are sorted by ID, that is natural ascending order. For the second one it is sorted by marks. By default I got the minimum marks, so this is 10, then 44, 55, and this way the marks are increasing. Next, for the next one they say that you need to sort in the reverse order. Now reverse order of what? They didn't mention ID, marks, or something like name. Then reverse order of what? So that is the reverse order of the natural. So you know that by default naturally they are getting ordered by ID. So when they say reverse, so that means they want reverse of the IDs. So again, one option is we can go back to the employee, we can interchange these two and we can do, but again that is not a good idea. Other option is we can make usage of this sorted, we can write something here. So let's see if that can be done. So first just write it as it is, and let's remove all these extra things too. And here let's copy this whole sorted from this particular part. So we'll say copy, and we can just keep it out here. And here instead of marks, since they are saying get ID, so we know by default they are on the basis of ID. So what we will do is we will just reverse these two so that it gets reverse of the natural order. And now if I execute this demo number 5, so let's see the kind of output we are going to achieve here. Okay, so yeah, this is fine. It is the reverse order of IDs, so that's good. But then again it becomes difficult. because now you need to remember what was the natural order on. You can't make usage anything directly here. So for this, what can we do? Can we make it even more simpler, that without using anything else, if we can use them? So that can be done with the help of comparator here directly. So again we will say comparator. This is the comparator, and then upon this comparator we will just say dot reverse order. So this is something which we can get, and it returns a comparator that imposes the reverse of the natural ordering. So this is how it is going to look like, and we'll just say here Control S. If I open the declaration, it is going to look something like this. So what it will simply do is, it will by default going to execute your this normal sorted first, and after the normal sorting it is just going to execute the reverse method. So that is how it will come to know what was the natural order and then how to reverse it, and you don't need to define that how to reverse the same. So now if I say again the output is same but without doing anything much. So yeah, this task is also done. So by now I hope that you have learned a lot about streams, and since many more things are going, but you know this video is big, so you should like the video and subscribe it also, so that it keeps on giving me motivation parallelly. Otherwise it won't be beneficial for all of us. So let's move on with the next one, even if you are not going to subscribe here now. So for the next one, again they say filter. We have already done this, but let's see what it says. So this is sort the employees by marks in the ascending order. Okay, let's do that first. For the marks, what we can do is, let me just copy paste from the previous one, if that is allowed. So I'll copy the previous one and I'll paste here. I mean, I'm lazy. I agree that I'm a little lazy here, and I'm not going to save it anywhere, and I wish to print it here directly. Okay, I have done this. It's very simple. So sort employees by marks in ascending. Yes, I have done. Print the employees, that I have done. But then they say get the employees with marks more than 50 only this time. Okay, so this is new. So after sorting, we want to filter out. So we can do here, but then I need to scroll. So what I'll do is, first of all, I'll divide it in multiple lines like this. And after this I'll say dot filter, and on filter we know how to work with the filter. So filter is going to take your employee, and this time it will say employee, then it will say get marks something this, and it says greater than 50. So we'll say greater than 50 here. Fine. So first we are streaming, then we are sorting, then we are filtering, and then we are printing them. And as of now, let's comment other things here so that we again don't get confused, and let's see the output. So this time this is your output. So they got first of all sorted by their marks, and then we have filtered only those whose marks is more than 50, and then we are printing them here. So we got the output. Yeah, this is fine. Now there are two more different ways of doing the same thing. Now here, if you try to understand what it is saying, the other way of saying this same story is that sort the employees by marks and then only get those employees whose marks is more than 50. Like when we say filtering, okay. Now that means that we should be dropping the initial employees whose marks were not more than 50. So let's see the other way of doing the same thing, but without the help of filter method. Obviously we need to sort the things again. So let's copy the things here somewhere, this one, and again we don't need anything like this, so that we can remove, and let's remove this part also. So yeah, here it goes. So this we have sorted, and this, but this time we are not going to use filtering. We will have one more method, and that is, we will call it as dropWhile. So this is the one which we are going to use, dropWhile, and this also takes a same predicate. So here it goes, and this it says that dropWhile, which means just keep on dropping till the point marks are not greater than 50. because after 50 we need to get them. Before 50 we should drop them. So I'll copy this one and I'll paste it out here, but I will reverse the condition and I will say if marks is less than equals to 50, then drop, otherwise only take. So now again if I execute, so it is going to provide me the same output. You see 177, 29, 101, 102 and the same kind of output. But it is a different way of saying. I'm not saying get the employees whose marks is more than 50. I'm saying drop the employees whose marks is not more than 50. So this is the way we have done. Now it will give you one more benefit. The benefit is that when you work with the filter, then it executes all the elements and then it identifies whether the marks were more than equals to 50 or not. But when we know that if we have a particular sorted list, so once the marks of one employee is 50 or more, then for the next employee the marks cannot be less than 50. That is for sure, because we have just now sorted by marks. So when we are sure, then for the next employee we should check again whether his marks are more than 50 or not. So hence what we are doing now is we are making usage of the dropWhile. So this time we don't need to check again and again. We will just check till the point where marks are less than equals to 50. The moment marks will become greater than 50, we will stop checking the things and then we will just simply print, because now we know their marks is more than 50. And this is going to make your code even more faster. So this dropWhile method was not there initially. It came in Java 9 only, which we can see here that it is since Java 9. So this is how it is going to work. Hope you understood. Now the next is takeWhile. So again it says the same condition but with a different way again. So let's see how we can do it this time. So again we don't need anything like this here. Let's take the sorted again here as it is. So here we are taking and here we are taking this one. Okay. Now this time they are asking us to make usage of takeWhile. So now what they wish to tell us, they say only take if marks is greater than 50. Only in that case we should take them. So we will say takeWhile, again it's a predicate, and we will say when the marks is more than 50. So if the marks is not more than 50, we are not going to take them. But let's see if we execute, will it work fine or not. So yeah, we didn't got any kind of output. That is strange. Why so we didn't got any output? The reason is that why we didn't got any kind of output, because after sorting they got sorted in the ascending order. So the very first marks was less than 50. So hence it never got a chance that marks will become greater than 50. So we should reverse the condition like this. We should sort it in the descending order, and here also let's change it and say descending order. Sometimes we can change the question also. So we'll say descending order. Now the marks are in the descending order, and we will take the marks only till the point they will remain greater than 50. The moment it will become 50 or less than that, we will stop filtering, and then we don't need to check again and again. Now if I say execute, let's see how it is going to work. So this time the output will look like this. Obviously it is not sorted in that order, but you see again we are getting marks greater than 50 only. So this dropWhile and takeWhile are the new methods which were introduced in Java 9. They were not even available in Java 8. Before that, filter was only operation. But the disadvantage with filter was that you need to check the marks again and again for all the employees. But with dropWhile, the point is that once you are sure that this condition is met, then you don't need to check again and again. Initial one will be dropped and rest of them will be taken. For this takeWhile, only the marks will be taken, or only those employees will be taken whose marks is more than 50. Once it will become equal or less, it will get automatically dropped. And for this, I hope you got the thing that the minimum requirement is that your data should be sorted in that particular order. If the data is not sorted, then we can get any kind of output. Then we will not have any kind of surety. So dropWhile and takeWhile you can use only when it is a sorted data. Filter you can use anytime without even sorting. So these are the things, and you can just keep on trying this more in order to get a better idea. Now the next one is that we can make usage of maps here, something like map. So let's see what is the question. So the question is that create a stream from the given list. So yeah, that is created. Print the name of employees only. So first of all, we need to get the names only, and then we need to print. So currently, if I say here that this is my stream, and then directly I wish to print it out. So let's see what it will print. So I'll say Control S, and if I execute, it is going to print me everything, the full employee details, but I just want a name out of it. So one option is that you go to your for each and there you say employee, and then you say sysout employee.name, something like this. So let's say employee here, and then here we will have sysout something, and then we will say employee. So this is one way of printing the employees. Again, shortcut, no need to learn. Okay, we made a mistake. Okay, again we are printing employee only, but we need to print the name. Okay, we should not be that fast and furious. So now if I execute, we will get only the names. But here what we did, we took the whole employee object first, and then we are printing, and then we need to write this whole long thing also. So instead of doing this one, what we can do is we can move it back. So let's move this back to the old scenario, and let's try directly. So that means that from the employee, we want to create a kind of a map, and we need to get only the names out of it. So let's try to map them. So here we will say, in the next one, say enter dot map. Now what map does is, map takes a function, and function, you know, it will take something, it will return something. So again that is the reason last time that I said you that you need to be very clear about the 4 basic functional interfaces, because only they will keep on getting used in all your streams. So we will get the employee, and from the employee we will only say we wish to get names. So here this is the one. So we will get map the names from this. So for every employee we will map it with a name, and then on this name we are going to print. So now if you see, this map is not going to return you a stream of employee, it will return you a stream of strings. Which strings? Names only. And this way I hope it is clear that if you wish you can get only IDs, or if you wish you can get only the marks. So all that thing is again possible here. So now our next requirement is that we need to create a stream from multiple lists. So first of all, let's create another list for this. So we'll copy this one, we'll paste it out here, and let's say employee list 2, and here let's say populate employees 2. So we got this one. Now how we can do that? So let's make usage of stream and this .of method, the one which we used earlier also, to directly create a stream from the data. And here let's pass on these list. So we'll say employee list, and here also we will say employee list 2. So this is the one which we got here, and the output. So this output is a stream of list of employee. So it is not a stream of employee, it is a stream of list of employees. So it's a bigger one. Let's see how this looks like. So it looks like this: stream, and then your list, and then your employee. And upon this it says stream, that is your variable, and this. So this is a bigger one. Now upon this, can we directly make usage of this? Let's see. So if I say here stream, then this is not going to work. The reason why this is not going to work is because we cannot get a name from a list of employee. We can get a name from employee, but how to get from list of employee. So for this, we need to flatten this stream first. So currently it is a stream of list of employee. We need to flatten this and make it simple, and we need to make it like a stream of employee. Now for this, we will say stream dot flatMap instead of a map. So map is used for the normal functionality whenever you want to just get a data out of it or you want to do some mapping. flatMap is used when you want to work with some complex streams like this, stream of list of employee. Now from this, I just want to convert it to a stream of employee. So that one. Now flatMap also takes your function only. So this time it will be a list, and what it will do is it will convert it to a list to stream. So this one it will do. And this output, if you see, is now a stream of employee. And now we can directly make usage of this one. So this is going to work fine for us. And now if I execute, the output will look like this. So this is your output. So we are getting the data from 2 lists this time. If we wish, we can make it even more cut short. So we know that this stream method is available for this collection only. It is not anything specific for this list. So we can directly say collection and then colon. We can remove a dot. We can remove these arguments and we can just say stream. So this is going to work, and let's say Control Shift O. So if you want to know how this magic happened, then you need to check out our video on the lambdas. The next one is for this one. Now you see we are just getting a name, and this name is available for employee only. So this also we can make cut short. So we will say employee class. Here we'll say double colon. Let's remove this and let's make something like this. And same thing, if you wish, we can make it here also. And all this is explained in detail in lambdas video. So this is how we can work with the map and flatMap, guys. So these are some of the methods which we have discussed here. Now let's move ahead with our next demo and see few more extra methods. So with the next one, again we have this entity, and then we have this utility class available. So these are same. This time we don't have that another populate employees to method. And here we have this demo1. So let's see what is the requirement now. So this time the requirement is that we need to create a stream from the given list. Yeah, we have done. And we just need to count the number of employees. So this time we don't need to print the data as it is. We need to just count the total number of employees in this list. That is a single number we want to sync, and that we need to print here. So for this, what we can do is we have a method as dot and count. So the method is there, and the output is going to be a long, which means it's a terminal operation. So we'll use this, and output is this time a long. So we will just say here long count, and yeah, that's it. So here I will say sysout. We can't use this for each this time, and this is your count. This is the way this is going to work. And if your job is that simple that you just wish to count only, then you should not use this. You can make directly usage of list.size. I mean, that is going to be much more simple. But if there are multiple operations, like you want to sort, you want to filter, you want to distinct, and you want to do something else also, and then at the end you want to count, then this is a very good option here for the count. Now let's see the next one. Now in the next one, they say there is something like peak here. So let's see what is the need of this peak. So first they say create a stream from the given list. Okay, we have done. Then they say print the employees. Okay, that's not a big deal. We will just say here for each, and then we will just say, I mean, that's a simple. We will just say here sysout, this one, or directly shortcut will not work here. So let me say system.out, then colon colon, and then let me say println here. And here let me remove all these extra things so that it starts working. So yeah, this was simple. We have just printed it. Then they say now count the number of employees. Now that is going to become difficult, because after for each we can't use, because for each is a terminal operation. One operation is we can say employee list, then we say stream, and then we again say count, but that is not the requirement. So we want to say after this, and hence that is not possible, which means that whenever you are working with the streams, many times the scenario will come that you want just to print the data in between to see that if there is mistake, then what is the reason of that mistake. Now in all those cases, if you will make usage of for each in order to print, it will become difficult. Other option is you say we can make usage of some filter or something else, but then also it is some wrong idea. We will say that we will use some dummy filter and then in the body we will do that particular thing, but that's again a wrong thing. So the method which they say we can use is peek. So instead of for each, we will use peek here. So what peek does is peek also takes a consumer, but the difference between peek and for each is peek is a intermediate operation. It returns you a stream only. So that means after this again we can say count, and this is how the things are going to work now. So we will just say like this. So employee list dot stream, then we are just going to peek over this and then we are going to print data. And let me copy this system of count here and let's write it out here, and let me just copy this one also. I mean, we can be little lazy like this whenever we are making such a big video. So yeah, this is the one. Let's see if this is going to work or not for us. Okay, on executing this, I'm still getting 6 only. That means peek didn't work. So what was the purpose of this sysout? This sysout got completely ignored. So isn't it interesting that I wrote sysout in between, but then also it didn't work. The problem is that peek will work only when you are going to force over it, because you know that streams are lazy. So stream sets that if you just want to count only, then there is no need of peek. I can directly do a counting. So hence this is an unnecessary thing. So if you want to make usage of peek here, you need to force it. And how we can force it? Something like this. So we will copy this same thing again. Let's say here, and this time in order to force, so let me first say here count 2 so that it prints something different. So in order to force this, after peek we will say a filter, so that it actually iterates over all the elements instead of directly counting. And here we will say employee, and we are not going to filter anything as such, but we will directly say like this: employee dot get marks. Now we know all the marks were greater than 0, so we will directly say greater than 0. Now this way what we are doing is that although we are not filtering out any element, because we know by default all marks are greater than 0, or if you want to ensure, you can say greater than -1. Obviously marks cannot be in the negative here. So this time it is going to force peek to execute this particular statement, and now if we execute, it will look like this. So now we have forced the peek. Now it can be any method, but a method which should force your peek. It can be any kind of mapping, any kind of distinct, any kind of sorting, but directly we can't make usage of count here. That is the trick, guys. So I hope this is clear, and this way you can make usage of peek any number of times in between, and generally we should use peek only to print the data for the logging purpose basically, or the debugging if possible, or like sometimes it can happen that you can change the data within the peek also, because you can try to set something, but it should not be used for those purposes generally. Now let's move on with our demo number 3. And before that, let's remove this unwanted import from here. And yeah, this is our demo 3. Now here they say that create a stream from the given list. Okay, that is done. And let me remove this unwanted thing here. Print true if all the employees have marks more than equals to 60. Else false. So we want to print true if all the employees have marks more than 60. and we just want to print true, nothing else. Okay, so for this what we will do is we will make usage of one more method as allMatch. This one, allMatch. Now this allMatch is going to take a predicate and can return you a boolean. So here we will say employee, and the condition if all the marks are more than 60. So we will say employee dot get marks, and there we will say greater than 60, and this output is going to be a boolean here, guys. So we will say boolean, or let's say boolean result, and this is the one. And now we can say sys out here, and we can say result. So what it will do is it will check if all the employees satisfy this condition, then only it will say true, otherwise it will say false. It's a kind of filtering also. I mean, what we can do is we can filter first, then we can count, and we can check if the value of count is the same as the initial count, then say true, else false. But this is a shortcut. We don't need to filter, we don't need to count, we can just say allMatch. If this condition matches for all, then only it will say true, and it will look like this, false, because there are employees whose marks is less than 60 also, hence it is false. So even if one employee has marks less than 60, it will say false. Now it says anyMatch, which means if at least one employee is having marks more than 60. So for this, let me again copy this one first here. Let's say this is a result 2 this time, and we are going to print a result 2 here, this one. And this time we don't want to say allMatch, but we want to say at least one, which is anyMatch here. So this is the one, and condition will remain same. So now even if at least one employee has marks more than equal to 60, we will say true. And let's execute this again. So we will get true because there are employees with marks more than 60. Now the last but not the least here. So in the next one, they say that noneMatch. Okay, let's see what is the requirement here. Print true if none of the employees have marks more than 60. So you can say this is the reverse of allMatch. So maybe here itself we can say less than, but there is one more way of doing the same, and we will do that. But let me just paste it out here and paste this thing also here so that we can save the result somewhere, guys. So this is result 3, and this time we can say here noneMatch, and we can have this same whole condition. So this is how this is going to work. So this is ensure that none of the employees has marks more than 60, or if you wish you can just reverse the condition. I mean, that is also fine. But yeah, these are the things which you can use. Some more methods which we have seen here: allMatch, anyMatch, and noneMatch. Now let's move on with our next demo, next example here. So in the next example, again we have an entity, this is same. Again we have a utility, this is same. And we have 3 demos. So let's go for the first one. So this time they say create a stream from the given list as always. So yeah, this was there, let's remove this. And then they say get the employee with the minimum marks. Now generally you know that if you want to do some thing like this, you need to perform some bigger task. But here we can do this in a very easy way, and let's see how we can do this. So on this we will say dot, let's see if we have anything like min. So here we have a min here. So we'll go for min, and it takes a comparator. And for comparator, you know that we have worked with this comparator earlier also. So let's directly write this comparator. So we'll say employee 1 comma employee 2 here for this one, and let's say this bracket, let's say arrow, and then we have a body. So we'll say employee 1 dot get marks for this one, and then we will say minus, and let's say employee 2 dot get marks for again this, and yeah, that's it. So this is going to return us a minimum, and now the answer, we can save it out here, but the answer is optional of employee. So this is optional of employee, which is fine. But what is optional? That is not fine with us. So as of now, let's write there is something like optional. Okay, let's say optional, and let's see this employee, and let's call it as optional only. Let's say optional 1. So this way, let's say Control Shift O. So this optional is again something which was introduced in Java 8. As of now, if you don't know, it is fine. Let's don't spend time on that optional as of now. For this, we will have a separate video where we are just going to discuss on optional. As of now, we will assume that there exists something like this optional, and our job is just to print this one. So in the next statement, we will say a sys out here, and let's say optional 1. That's it. So when we execute this demo, we can get some answer. Let's see. So yeah, the answer is 101, and yeah, I was having the minimum marks, so my name got printed out here. And since it is not an employee, it's an optional of employee, so we are getting this optional also here. So this is the way it is going to work. More details on optional we will see in some different video. Now the next one is maximum marks we need to get. So again, we will copy out this and we will paste it out here. Let's say this one. Now instead of min, we will make usage of max. Again, this is possible, and this will also give me an optional. So let me just go here and say this as optional 2. And now if I say sys out and something like this, and say here also optional 2, so this should work fine for me. I hope that there is no issues with this, because the implementation and everything was same. Min, max, both of them are going to use comparator. Condition you need to write, so you don't need to have any kind of big for loops. So the person with minimum marks is me, the person with maximum marks is Yuvraj, 90. Complete different marks. After adding R marks, it can become 100 for sure. Let's see the next one. So in the next one, here they say that create a stream, that is done here, get the first employee. So what we can do is we can say limit 1, but instead of it, let's try out some different method also. So here we will say find first, something like this. And for this find first, let's see the kind of output. So the output is an optional of employee again for this. So let me copy this optional of employee from here, and let me go somewhere like this. And if I say I can print this optional, it will be great again. So let's say optional 1. So this is how this one is going to look like, and the output will be, it will always return you the very first employee with a guarantee. Now in the next one, they say that you can find any. So let me just copy this whole, paste it out here, and the only change which I'll do is, instead of saying find first, I'll say find any here. And this I'll say as optional 2. Here I will say optional 2, and yeah, this will work like this. Control Shift O, and on executing, it gives the same answer. But the point is that here this findAny is a different method. So findAny can return you any random output. So with the first one, there is a guarantee that it gives you the very first element, but this, there is no guarantee. It may give you the first, it may give you the last, it may give you any element out of your stream. Generally we use findAny when we are going to work with parallel stream, which is our last topic of the video. Let's move with the next one. And here they say that we need to go for something like reduce. So let's see what is this reduce. So they say get the marks of employees, add all the marks, and then print the sum only. So let's see. So we already have a stream here. So from this stream we need to get the marks. So we will make usage of map, as you know, and here we will say employee, and from the employees we will get their marks, employee dot get marks. So now this becomes a stream of integers, stream of marks only. It's no more a stream of employee, but we want a sum from this. So we will say dot, and here we have a method as reduce. So this reduce is going to take a binary operator. Operator, again, as you know, something which is going to take same kind of input, same kind of output. The difference between binary and unary operator which we did earlier was binary can take 2 arguments this time. So the very first one will be the marks 1, and then the second is going to be your marks 2, and this is the 1, and let's see what we wish to do here. So we just want to add these 2 marks, so we'll say marks 1 plus marks 2 here. Let me remove this comma. So these are my marks 2, and after this what I wish to do, so this reduce is going to return me, let's see what kind of output it returns. So this returns me a kind of an optional integer. So let me copy from this one, this optional of integer, and here I will paste it like this, and this is an optional of integer basically. So I'll say here optional of integer, and this is optional one, yeah, that is fine. And let me say sysout. So on this sysout I will get optional of 1 here, and now this also, if we wish, I can just paste it out here in the stream. So no need of all these things. I can say Control Shift O, and this part let me say Control Shift F here, guys. So first I took a string, then I convert it to marks, and then with the reduce I'm making a sum of this. And if I execute this one, the last, so the output is 319. That is the total sum of marks which are available here. Now let's see the last one part of this particular demo only. So here they say that on the overall marks you need to add 1000. So how that can be done, how we can add 1000 to the overall marks? So for this, reduce has one more overloaded method which takes initial identity. This is again like your seed. So there we can say 1000. So this means that whatever the marks it is going to provide me, those marks will be added here. So this is the output, and this time since minimum answer is going to be 1000, so it is not going to be an optional, it is going to be a normal integer, because it's a guarantee this time. Previously there was no guarantee, it can be empty if your list is empty, but now there is a guarantee, and hence no need of optional, and something like this should work fine. On executing I will get 1319. So this is the way it is going to work. If you are not clear about optionals, no need to worry, maybe you can skip this demo 4 also, and in the next video we are going to discuss more about optionals in detail. So in the demo 5, again we have an entity class, then we have a utility class here, and then we have this demo 1 class. And this time what they say is that till now, if you remember, how did we started our things? So we started our things by converting the data from different kinds of collections to stream. But now this is reverse. From the stream, we need to sync a particular kind of collection. And the first one is we need to sync an array here. So let's see how we can do that. So for this one, in order to sync a kind of a collection, we will just say here dot, and then we will say toArray. Now this toArray is, let's see what it is going to return me. So this toArray is going to return an object of array. But what if we want to get an object of employee here? So for that we need to do something like this: employee, that is an array, colon colon new. This is again your method reference. So this way you can get a employee array from this, and let's save it to this particular employee array. So let's say employee, this one, let's say array here, and let's save it out. And now we need to print. So for array we don't have that for each method still, so the only option is to print it like this. So let's say employee, let's say array here, and let's say sysout, and let's say employee. So this way we can print our employee. So yeah, this is the one, our very first one, collect to array. So now this is from an array, not from a particular list or anything else. We are getting other data, but that is the direct one. But this is, as you can see, it's from an array. Now the next one, they say that we need to get it from a list, or we need to convert it to a list. So let's see how we can do that. So for this we will say dot, and the method is collect here. So we will say collect, and in this collect methods, what is the kind of argument? So the argument they say is a kind of collector. So we will just say here collector, and to this collector we can directly say dot to list. So using this we can convert this back to the list. So we'll say this, and here it says to list is undefined for the type of collectors, because what was wrong here? Because it is not collector, it is collectors. So that I need to use out here. Now we should not use something like this, and instead I should say here it's a list here, and let me make it also as list. So this is the one, guys. So what we have done is we took from a list, we converted it to a stream, and then again we collected it to a list. So it worked like this. Now the next one, they say collect to a set. So without doing anything different, we'll just copy this out, we'll paste it out here, and we say, can we say here to set? Let's see. So we'll say to set, and yeah, this is also done. So we can directly convert it to a set. Let's rename all these things. So we'll say set here, and on set also we can use for each here directly. That was possible again. So now let's move on to our next one, where we want to collect it as a map. Now this one is going to be little difficult. So we will again copy this one first, and we will paste it like this, and here we will try to say collect dot to map, and let's see this will work or not. And yeah, so this way we can say to map because the method exists. But the point is that when we are saying map, maps are little different. We need to tell what is going to be the key, what is going to be the value, and we need to say that key should be the employee ID and value should be the whole key employee itself, the whole employee object. So for this we need to write it like this. So first of all we'll say that employee, and then we will say get ID. So your ID of the employee is going to be the key here, and then you are going to take the whole employee object as it is. So this way we are going to take the whole employee object as it is for the second part. And then after this we need to say that two employees should be, on what basis we need to check whether the two employees are same or not. So that also needs to be taken care. So for this we will say here employee 1 comma employee 2. So why this is needed? Because if you remember, in maps we cannot have two duplicate IDs. So we need to tell that if two employee IDs are same, then which one should be taken. So hence this last one is needed. So here we will say employee 2. So we are saying that always override with the next one. So this we have written here, and let's convert this one to map, and with the map we were having this as integer, the second one is an employee only, and yeah, this way it should be working fine. So this looks a bigger now. So first we are saying what should be the key type, that is your ID. Then we say value should be employee as it is, and then this last is needed to tell that if two IDs are same, then which one to keep, first one or second one. So we are saying keep a second one if two IDs are same. And for this map we can say map dot for each, but you know this is not going to work directly, so we need to convert it to an entry set first. So we will say entry set, and now this should be able to work fine for us. So now let's execute this demo and see the output. So let's see if we get the required output or not. So first of all, we get an array of 6 items, that's fine. Then we get a list of 6 items, this is also fine. And then we get a set of again 6 items. But why so? This is little wrong. We should not get 6 items in the set. We want that if 2 employees have same ID, then only one of them should be printed, not the second one. But how to tell set this time here? So for this, we'll go to the employee class, and here we will say that compare two employees. So for this, we will do with the help of equals method, and we will compare them on the basis of IDs, and let's say Ctrl Shift O, Ctrl Shift F. So this is the one. Equals method has been overridden. Now let's execute this again, this demo1 class, and this time we see that in the array we have 6 items, in list we have 6 items, in set we have 5 items only. When the two IDs are same, only one of them is considered, second one has been neglected. And in the maps again we have only 5 items, not 6, and which has been taken? The second one has been taken. Why? Because here we have mentioned whenever 2 employees are same or 2 IDs are same, always take the second one. If you say here employee 1, it is always going to take your first employee. So this way we can convert again from stream to collections. Now let's go on for the next demo. So in the next one, they say that we need to group the employees, but wait, we hear this groupBy thing whenever we are working with the SQL. So there, if you remember, we can have something like groupBy. So we can say select star from this, where this groupBy, and then we have some groupBy and having conditions also. But same thing we can utilize here too. So here they say that group employees by employee ID. Now generally we were having only single employee ID, but we know that for 2 employees we have same employee ID. So let's see how this is going to work for us. So here we will again say dot collect, the same method, and this one is again the same collectors we are going to use, and this time instead of saying list, set or map, we will say group by. So this is our grouping by method. So we will say grouping by. Now this is going to take a function here. So again we need to tell it on what basis. So we will say that on the basis of ID you need to group by. So this is ID, and then we also need to tell it that after grouping by what it should do when there are multiple values. So it should be creating a list for them. So we will say collectors dot to list. So if there are multiple values, then create a list of them, not a set or a map or something like this. So this is the one, and the output of this group by is again a map. So let's write here as map. Now we will be obviously grouping on the basis of ID. So the key is going to be your integer. So let's say here integer this time, and this is the output is not an employee but a list of employee here. So let's say list, and let's say here something like this. So let's say Ctrl Shift O. So this is the one, and here let me rewrite it as map, and let me here also name as map and say entry set. So this is the one, guys. And now if I execute this demo2, the output will look something like this. So I'm using here groupBy, and you see that for this ID 101 I have a list of 2 employees, and for this I just need to make usage of grouping by. So that also can be done. Isn't that interesting? SQL is also coming here. Now the next one is they say that group employees by marks. But it is not only by marks that we say that okay, if all the employees have 60 then make single group, if have employees have 50 then make another group. They say all employees with marks equal to and more than 60, one group. If marks are less than 60, second group. So for this, our group by is not going to work. So let's try to make usage of something different, and here we will say dot collect again, and with the collect here we will say again collectors. So this is our collectors, but instead of grouping by we will say here partitioning by. So spelling got wrong here, so we'll say collectors dot partitioning by, and in this partitioning by we need to tell here that on the basis of marks. So we will say here employee and employee dot get marks. So first group will be for those where marks is greater than equals to 60, and then here after this we will say that it should be able to create a a list for all the employees if there are multiple employees. So let's tell that too. For this, let me just copy this first one. So I'll copy, I'll paste it out here, and here let me say this semicolon, and the output will be again a kind of map only. So let me create a map here. So this is the one. If you want to know how I came to know, so you can just take it here. So it says it's a map of boolean and list this time, not an integer. So whenever you will do a partitioning, it will create two parts, one with the key as true, other with the key as false. So this is my map 2. Here also let me see here map 2, and here let me make usage of this entry set, something like this. So this is our entry set, and if I execute we will get output like this. So we have divided it in two parts. Whenever it is less than 60, so the key is false because of this thing. So we are saying greater than equals to 60, hence it got as true, other one as got as false, and this is your list. So we got a list of all those employees, and since my name is coming on both the sides, so I am a part of both the partitions. So this way we can do something like grouping by and partitioning by also. And similar to this, there can be many more methods here, and if we keep on discussing, the video will become an infinite video, which we should not make. So let's stop these methods here itself, and let's move on with the next topic. So our next topic is that we need to prove that streams are lazy in nature. So we have heard till now that okay, streams are lazy, but okay, what is the proof? So let's check it out now. So for this we'll go for demo 6, and here we see, so again we have the same entity, we have a same utility, and here we have just single demo. It's not a big one. So here they say create a stream from given list, that's ready with us. Filter employees by marks more than equals to 60. So let's do that. So we'll say stream dot filter, and then I will say here employee, and then I will say here employee dot get, not class, I want it to be marks, not class. So I will say greater than equals to 60 here. So this is the one. Then they say print the first filtered employee. So only the first one they want to get from this. So we will say find first here. So this way we can ask it. So we will say find first, and then they say print the employee. So find first is going to return you something like an optional in nature. So let's see, or in this one I want to show you that streams are lazy. So instead of writing them together, let me write them separate so that it will become more clear. So this is my original stream, and this is the filtered stream here, and upon this filtered stream we have made a find first. This one, this is going to return me an optional, the optional of employee. So let's say here optional of employee here, and let's say this one as employee, something like this, Control Shift O, and let me print this thing also. So I will say sys out here and employee, this one. So this is the thing. Now they say that print employee before filtering, during filtering, and after the filtering. So I want to print it at different times. Again, I can't make usage of for each. I should go by peak. So let me write peak at different points. So after this, I'll just say, okay, let me say it like this, and let me put it this one in this particular way. So now it looks nice. And let me say here peak, and in the peak I will just say sysout. So I will just say system, or we need to identify also. So let me write something different. So I will say employee will be the input, and in the output we will say it's a sysout, but not directly for the employee. Otherwise, how we will come to know that, okay, whether it got printed before or after, or which line got executed. So we will say here a word like pre-filtering. So this is the term which we are going to use here for pre-filtering. So this is done before filtering, and then they say that during filtering also. But during filtering, how can we do like here? So for this, what I'll do is I'll make usage of this one. I'll convert it to multiple lines, and there I will say here the term return. So this is the one, and again here I will say this particular sysout. So I'll copy this statement here, and I will take it to the next line, and here I will say filtering, something like this. So this one is filtering. Let me say Control Shift F. So now it looks like this. So first is peak, and let me move it to again the next line, then filter. There also I'm saying filtering, and then it says after filtering also. So let me again copy this particular statement and move it to the next line here. So this is the one, and now I'm thinking that I can make a single thing out of this now, because now we don't need so many things. So what I'll do is I'll keep all these things here in the starting at this point, and here I will say dot thing, and this is your findFirst. So, and this semicolon is also not needed here. So these are the streams, and this should not be employed because otherwise it will give an error. So it should be, let's call it as optional, and let's call it as optional here too. So this one, Control Shift O, Control Shift F also, let's say, and let me move it like this way. It looks fine to me now. So we are having a peak first, then filter, then peak, and then find first. And this also, let me make it more shorter this way. No need of this thing too. So I hope we are fine with something like this. Now, what do you think, how many times which particular line will be executed? So let's try to understand. Here we are having 6 employees in total. Now this stream should work for all the 6 employees. Then this peak also should work for all the 6 employees because this is before the filtering. So this statement should be printed 6 times. So let's write 6 after this, that it should be printed 6 times. Then we are filtering only those employees whose marks is more than 60, but still it comes in this filter part. So this also should be printed 6 times. And after filtering, only those employees will be printed whose marks is more than 60. And for this, let's check it out. So this will go, this will go, these two will be there, and this. So that means 3 employees are having marks more than 60. So this line should be printed 3 times, and let's call it as post filtering here for better understanding. So post filtering should be printed 3 times, and after this it should return me the very first employee who has marks more than 60. So in the output there should be 6, and then 6 12, and then 3 15, and then 1 for this, that is total 16 statements. Let's check it out. So when we print, we don't get those many things. Why so? Why pre-filtering didn't got executed 6 times? For it got executed for the very first one, that is ID 10. Then filtering occurred for it. Okay, that is fine. And then since this was not marks more than 60, so this post didn't went well. Okay, that is fine. Then with the next one, again 55 got printed, filtering got printed, that is also good. Then next employee was having marks as 60. So for this, pre-filtering got executed, filtering got executed, post filtering got executed, and then since we mentioned here we just need a single employee, so it said, okay, you asked me for a single employer, this is your single, why should I go after this? And hence we can say that streams are lazy in nature. So streams always work as per the demand. So if there is a demand of only one employee, then streams are not going to execute for the whole collection there as it is. Hence we can say that streams work as per the requirement, and hence they are lazy. Otherwise, imagine that if the same thing I would have done without streams, without lambda, with a normal way, then first of all I would have printed this statement, it would have came 6 times, then this statement would have came 6 times, and then this statement would have printed 3 times, but that's not a case. And hence we can prove that streams are lazy in nature, and that is the benefit here. So I hope now this is clear that why we say that streams are lazy in nature. And another interesting part is, if I won't say this find first, then this is not even going to execute at all, because then I didn't made any terminal operation. So now in the final one, let's discuss the difference between streams and parallel streams. So streams, we say, as we have learnt also, that these are the sequence of elements and are always processed in the sequence, line by line, first, then second and third. But then there is a parallel stream, and by the name also it suggests. What it will do is, it is going to do a parallel processing. You can say it is going to leverage your multi-threading here. So what it will do is, it will convert your source, or we can say it is going to divide your source into multiple chunks, and then multiple streams are going to start over those chunks. The benefit is the performance. We can get the same output quickly, and all other methods which we have studied with the streams, same can work with your parallel streams also. But does this means that we should always make usage of parallel streams? The answer is no. We can't go for parallel streams always. So let's see this with the help of a proof. So here we are with our last demo where we are going to prove. So we have this entity class as it is. This time I have a utility package, and this class is also same, and then there is a logutil class. Now this class is little different. Here I'm having a method log without sleep. So whenever I pass a particular string to this, it will just print. I mean, I could have printed it directly, but I want to compare it with this sleep method, hence I have mentioned it here. And in this method, if I pass a value, then it will print the value, but then it will sleep for 1 second. This thing I have shown in the video of multi-threading, that how we can write something like this, hence I won't go in the detail of it, but these are the two methods. So this will just print and come out, this will print but sleep for 1 second. Now let's see with these 4 demos how do things work. Now this is just going to be a comparison video between streams and parallel streams. All other methods can be used in almost a similar way, so hence we are not going to discuss all the methods again for the parallel stream. So here what we have done is, we are taking a populate employees method and we are getting a list, then we are converting it to a particular stream, then here we are mentioning the starting time. At the end we are going to print the ending time. This is your particular ending time, and we will come to know that how much time it took in total. Then we are filtering the employees whose marks with more than 60, something which we did just now, so we are using filter here. Then we are using the peak method before filtering and after filtering, just the same way we did now also. So this is the one. The difference is, this time we are not using sysout directly, instead we are making usage of that log without sleep. So we are passing this value and it will get printed there. Then this we are printing that it is going to be a string, and at the end this time we are going to print the count. So we are going to print the count of those employees whose marks is more than equals to 60. And as you can see here, I am not making usage of method with sleep, it is without sleep, so it will get called and it will print directly, and I'm making usage of streams here. So let's see how much time it is going to take. So if I execute, it will get executed something like this. So it is a pre-filter and filtering, then it is again pre-filter and filtering for marks, then this is for 60. Now this is not find first. Now since it is not going to be find first, I want the total count, so it is going to be executed for always. So for this, with marks equal to 60, it printed post filter also. Then with again marks equal to 60, it got post filter. For 44, only pre and filtering. For 90, post filter also got printed, and we got count as 3. So that was the way it worked, and total time it took is 25 milliseconds in total, which is a pretty less time. Now let's do the same thing but with a parallel stream. Now how you can make a parallel stream is you can do it directly. Like you can create a stream, you can directly say parallel stream, and that can work. Or the other way is that if you don't like this, first you can say stream, and then you can say here something like, I guess two parallel should work upon this. So do we have anything like two parallel or anything like parallel over this? Okay, I guess it should be somewhere here only, not sure where it went away. So this is stream, and yeah, this is the one parallel which I was looking for. So the method is not two parallel, it is parallel. So either you can say stream first and then parallel, or directly you can say like parallel stream. Both of them will be fine. Rest of the things are same like the first one, so that we can see the output here. So we are using same peak, filter, peak, everything is same. This is also log without sleep, and rest of the things are same here. Only difference is it's a parallel stream. Now as per the logic, since it's a parallel stream, it should divide your list in multiple parts, and it should be faster than the previous one. So last time we got output as 25 milliseconds. Let's see this time will it get less than 25 milliseconds or not. So on executing, the count becomes 30 milliseconds, which means that it is not true that we always multi-threading or parallel streams are going to help you out, because the data was too short. So in this case, what happened was that first you divided the things, and then at the end you are counting, which means you are rejoining the things. So the time taken for dividing your initial source in chunks, and then at the end combining the sum, so then that also took time, and hence it took 30 milliseconds, which is more than your 25 milliseconds of streams. So this means always parallel streams are not useful. But does it mean that we should not use parallel streams at all? Let's again see with the next demo. So in the next one, we are doing the same. We are using same stream this time, and the difference is we will be saying log with sleep, which means after every printing, it will go to a sleep of 1 second, and rest of the criteria is same. So let's execute. So without sleep, it was 25 and 30. Let's see what happens. So you see it is slow now. Pre-filtering, filtering, pre-filter, filter, again pre-filtering, and then post. One by one it is working in the sequence. So obviously it will take more time now, and the time is around 17,211 milliseconds. So when we are sleeping after every printing, because maybe we are lazy, so it is taking more time streams. So let's see, will parallel streams will be able to beat this time or not now, or again will the stream be a winner? So let's check it out. So for this, again what I have done here is something like this and something like this. Everything is same, all the criteria. This time parallel stream is also using log with sleep. Let's see. So the time was 17,211 milliseconds to beat. Let's see. So this time if we execute, so we go for parallel stream, and you see they have now did their work. So this time, since after every printing, every thread will sleep for 1 second. So all the pre-filtering happened together. They got printed together. Then filtering got printed together, because there also after every printing it sleep for 1 second. And then post filtering got printed. And this time we can see that actually they are working in parallel in more better idea. And the time is almost 1/3 of your actual stream. It is almost like 5071. Streams work the same thing in 17,000 milliseconds. So now we can say that although it took time to divide the source in chunks, although it took time to concatenate all the output at the end in order to get a total count, still the parallel streams performed well. So this is the way. Hence, we should never say that always parallel streams are useful or always streams are useful. It again depends on the requirements. Sometimes there are some operations. So let's say you did a parallel streaming, but at the end you said sorting. There was no benefit of parallel streaming if you are saying sorting or counting like this. These parallel streams are helpful when you are doing something like for each or findAny at the end. Then they are more useful, or in such kind of scenarios when you feel every operation is going to take a long time, and hence wisely you should decide which one to be used. So this was the last demo, guys, and I hope you have enjoyed this video. And if yes, please do a like and share this video with others. Please subscribe to our channel also. And in the next video we are going to discuss about optional class in detail. Thanks everyone.